Hello again. Now, at the end of the first video, we talked about how what negative exponents and zero exponents mean, how they're interpreted, and also why they work out the way that they do. And at the end, we mentioned that if there were there's some questions on your assignment that might be a little bit tricky, and so you should try to work through them. Hopefully, you already have tried to work through them at this point. But they obviously are a little bit difficult, and so we'll talk about a couple examples here now, mostly dealing with the negative exponents, and then hopefully that'll be enough for you. Of course, if it isn't, you know where to go. Talk to your teacher, go to the Mathio, go to the homework help, lunchrooms, things like that. You have options. But keep in mind again, the general idea. A to the 0 is equal to 1. Anything to the power of 0 is equal to 1. Anything to a negative power is the same thing as 1 over that thing to the positive power. So a negative power means take the reciprocal. It might make more sense perhaps to think of it like that, but whatever. So an example. Let's do a really hard example. I have one written out here. 49 x to the negative 3 y to the 4 divided by 35 x to the 7 y to the negative 4 z to the 0 all to the power of negative 2. There's a lot happening here. There's a lot to do. And there's a different order in which you could do things. Because you have order of operations, but really everything's multiplication. And yeah, you got the parentheses, you got exponents. There's kind of a little bit of a difference in what you can do. Different cases, it might be easier to do things in different ways, but this will be my general strategy. I encourage you to use this strategy as well. When the power outside is negative, that should be your first step, is to make it not be negative. The negative power, again, means we take the reciprocal. And so I'm going to flip this whole thing. I'm going to erase it, though, and rewrite it, because I want to make sure I have enough room to write everything. So I'm going to change this to a positive 2. So that's now a positive 2. And in doing that, I'm flipping this fraction. I'm not doing anything to the inside apart from flipping it. So now it's 35x to the 7, y to the negative 4, z to the 0 on top, and 49x to the negative 3, y to the 4 on the bottom. So that's the first step. Take care of that big negative exponent, the negative exponent on the outside. The next part kind of varies. I'd recommend continuing to take care of the negative exponents. We have a y to the negative 4, we have an x to the negative 3. That means that they need to flip where they are. So, again, I'm not going to do anything with that big exponent out there, not yet anyway. 35, now this x to the negative 3 is going to move up to the top. The x to the 7, though, that's a positive exponent. That's going to stay there. The x to the negative 3, that'll move. The y to the negative 4, that'll move. Nothing else is going to move. So we're going to have x to the 7 and then x to the 3 on the top. And then the z to the 0, well, the z to the 0 is just 1. We don't even really need to consider that anymore, because the power of 0 means we turn it into 1. And we could write a 1 as a placeholder. That's not really worth it. That y to the negative 4, that's going to go to the bottom. So we have 49 y to the 4 that was already there, and then the y to the 4 that we moved down there, and then finally to the power of 2. There's still that big power of 2 on the outside. Now we can simplify some stuff. I got x to the 7 times x to the 3. Now I could write out all of the x's, all of the 7x's, and all of the 3x's, but hopefully at this point you've realized that we can shortcut that by just realizing that that is going to be x to the 10 on the top. This down here, y to the 4 times y to the 4, we add the exponents and get y to the 8. Now, the 35 over 49, we haven't done anything with that. Yet we can. That is a fraction. We can kind of think of it on its own. 35 49ths. They have a common factor. We can take a 7 out of both of those. And so we get a 5 on the top and a 7 on the bottom. And then that whole thing is raised to the power of 2. And so now, now that there isn't anything more to simplify in here, there's no canceling. Maybe on some of the examples you end up with some x's on top and on the bottom, and you'd have to cancel them as a second step. But not in this particular example. Now I'm going to use my power of 2. Because what this means is that I have 5x to the 10 times 7y to the 8 times 5x to the 10 over 7y to the 8. And of course I could just square each individual piece and think of it that way, since that's what we have. But 5 times 5 is 25. X to the 10 times x to the 10 is x to the 20. 7 times 7 is 49, back to the 49 again. Y to the 8 times y to the 8 is y to the 16. And so that is my final answer. So the general process, if the exponent outside the fraction is negative, deal with that first. Then deal with the individual negative exponents inside the fraction. Take care of those. Simplify what you get as a result, combining them on top and maybe canceling them up and down if there is anything to cancel. Also cancel the fractions if you need to, the numerical fractions. Reduce that. Once you get so that the inside of the parentheses cannot simplify anymore, then deal with your big exponent on the outside. Only then. And so then that we get to our final answer right there. So hopefully this process here is helpful to you. Again, take care of the negative exponents first, the big negative exponent, and then the individual negative exponents. Simplify what's inside the parentheses. Then, only after you've simplified that expression, take that back. If you're still having a little bit of trouble, again, go to the math homework help, ask your teacher. You know where to go. Take advantage of those helps.